we will start talking about graphing, work on quadratic functions and quadratic equations, and how to solve, how to graph, how to represent these quadratic equations on the XY coordinate system, right? Using lots of graphings. I think this week and the next week will be about it. And the next week, on the 13th is the last day. We're going to have a test. And this week, most of the time, we're going to work on graphing quadratic equations and quadratic functions. But before we move to the graphing thing, I want you to help me review the last topic we have seen last Friday, is to work with discriminants, using discriminants. And I agree that last week we had some hard work, even, I don't like to classify things as difficult, but even some difficult thing, like solving equations using substitution strategy. It's kind of hard, it's kind of difficult. But on Friday, we used this example here, is how to apply discriminants to find out if the equation that we are working on have two real solutions, one real solution, or no real solution at all. And this is one example. The equation 3x squared plus x minus 2 equals 0. We will apply that formula. This is the discriminant formula, b squared minus 4ac. To be able to find the answer, the result, we need to identify a. A here on the equation is 3. B is positive 1. And c is negative 2, right? So we have a, b, and c. Plugging into the formula b squared minus 4ac, 1 squared minus 4 times 3 times negative 2, and then you have 1 minus negative 24 is 25. 25 is the value of the discriminant. So we found the discriminant equals to 25. Now, can you tell me if this equation, the discriminant is 25, this equation is going to have two real solutions, or it will have only one real solution, or it's having no real solution at all? What do you think? Based on the discriminant, can you tell me? I will ask for help. I'm going to invite a couple of students to answer this question. So let me check who answered the last one. I'm not going to call the same students over and over again. And that's a question. Because if you remember this formula, you just need to remember this formula. And even if you don't remember, I will give you on the test. I'm going to ask a few questions about this because I think this is very useful and not hard, not too difficult. Apply, plug in the coefficients, find the value. If the discriminant is positive, you can say yes. If the discriminant is positive, the equation will have two solutions. If the discriminant is equals to 0, then you can say the equation will have only one real solution. And finally, if you have the discriminant negative, a negative number, you can say there will be no real solution at all. In this case, it's a positive number. The answer is two real solutions. That's right, Keon. Perfect. That's right, Alexis. Nice. Well done. And excellent. Moving on. Today we are working on graphing quadratic functions. And the first thing we have to remember, what is a quadratic function? We know a quadratic equation, let's say y equals ax squared plus bx plus c. This is a quadratic equation, right? What's the difference between this quadratic equation and a quadratic function? To find out if an equation is a quadratic function, you just have to check one little thing. For each input, it needs to have only one output. That means for each x, for each value of x, you're going to find only one value of y. And this is the case. If you try one value of x, in any situations, you're going to have only one value of y. That means this equation is a function. From now on, when talking about functions, we're going to use the function notation. And the function notation is this: f of x equals ax squared plus bx plus c. Instead of y, we will use f of x. This is function notation. So we know you don't need to try. I'm telling you, when I use the function notation, I'm telling you this is a function. You don't need to check. And we will work with graphing, but today we're going to focus in just one little thing, just one little thing, which is the vertex. The vertex of the graph. Okay? On the quadratic function, we have the graph of a quadratic function. It have a special name. We've learned this before. This graph, it looks like a U, right? Like a U, or even an upside down U. But it looks like a U. And the special name of this graph is parabola. When we talk about parabola, we know this is the graph of a quadratic function. And I told you, we will focus on just one little thing. It's called vertex. And the vertex is this little point here. If the graph is a U, like a regular U, is the point more to the south, more to the lower point. This is the vertex. And if it's an upside down U, is that point here, is the highest pointing, is the top of the hill, is the point more to the north. So this is the vertex. Today we will work on finding the coordinates of the vertex. Okay? So this is the vertex. Now let's check the situations we will find today. Let's say we have the quadratic function. The simplest one that we have is f of x equals x squared. This is one of the simplest quadratic functions, right? F of x equals x squared. And is this one here, represented on this graph in black. F of x equals x squared. If we have on the form x squared plus k is a number, let's find an example here. X squared plus 1. What happens to the graph? Check the picture, the red or pink graph, this one. If you add 1, like this is shown here, the graph moves 1 unit upwards. It shifts in the vertical line 1 unit. On the vertex, that's this point, more to the bottom, the lowest point, which was 0, 0. If for fx equals x squared, the vertex is x equals 0, y equals 0, the point is going to move up. And now the coordinates are x equals 0, y equals 1. Okay? So for x plus 1, the vertex is x equals 0, y equals 1. Right? Let's focus on this, on the vertex. And the next slide we have an example. m of x equals x squared minus 4. Let's say if m of x equals x squared, then we have the simplest one, the simplest kind of parabola or quadratic equation. This is x squared. If we subtract 4, we're going to shift this graph 4 units to the downwards. So 1, 2, 3, 4. Now the vertex is going to be here, and the graph will look like that. Check it out. It will look something like that. X squared minus 4. And then the vertex was 0, 0. Now we have the vertex x equals 0, y equals negative 4. Okay. The vertex is 0 and negative 4. And we're going to practice this on the quiz. Don't worry. We will practice this situation. We just have to check the other situation we will find. The next situation. If you have this form, f of x equals, and parentheses, x minus h, the whole thing squares. Let's understand what happened. The easiest, the simplest quadratic equation is this. F of x equals x squared. Again, the black one, the black graph on the picture. Now we will add 1, but under the square, x plus 1. Hello, Cynthia. Good morning. Okay, now we are adding 1. It's slightly different from the previous one, from the previous situation. Now we are adding, but inside the square, inside the parentheses, and this is being squared as well. Okay. If you check the graph, what happens is it will shift. But now instead of shifting up and down, the graph will shift to the sides. In this case, we'll shift to the left. And the vertex was 0, 0. After you add 1, the vertex will become negative 1, x equals negative 1, and y equals 0. So the vertex here is negative 1, 0. Okay, let me show an example, another example. If you have p of x equals parentheses x minus 7 squared, how do you find the graph of this function? Let's always start with p of x, the simplest quadratic equation, x squared, and then the vertex is 0, 0. This is x. This is x squared. Now we will subtract 7 inside the parentheses, the whole thing squared. When we do something like that, we're going to subtract 7 inside the parentheses. We will shift the graph 1, 2, 3, 4, 5, 6, 7 units to the right. This is going to be the new graph. X minus 7 squared. And the vertex now is x equals 7, y equals 0. A vertex equals 7, 0. Questions? What do you think? It might look a bit confusing, right now because we are beginning to work with graph, and maybe if you didn't try this before, it can look a bit confusing, but don't worry, we need to practice to be able to understand this kind of thing. We need to work on a few examples. You need to try by yourself, and I'm pretty sure you're going to be more confident after that. Any questions? Any comments? Any complaints? Any feedback? If you don't have questions, maybe you can move to the practice. And before moving on, let's try the bell work. No questions? Let's move then. And try to tell me the answer for the bell work. Send me a message. I need one message from each one of you. Each one, send me a guess. If you're not sure, you can guess. There's no penalty if you don't find the right answer. I need 11 messages. So Adrian, Alanis, Kalia, Chrisdiel, Cynthia, Jalexis, Juan, Keon Harding, Keon McCall, Maddie, and Makina. Send me a message for this bell work. What's the speed of the object? And the object, I think, is not a piano. I think it was a lighter object. But anyways, no matter the kind of object, the speed is going to be the same. 20, maybe 20. Chris Dial, 20. Maddie, 20. Thank you, Maddie. Thank you, Chris Dial. Send me your answers, Kalia, Cynthia, Jalexis, Keon McCall, Keon Harding. Thank you, Kalia. Maybe 20. Keon, thank you. Okay, Keon Harding. Don't you know who? Adrian. Alanis, send me a message, Alanis. Cynthia, I'm waiting for your answer. Makina, thank you, Makina. Three more seconds, then we can solve it. 3 more seconds as last chance for you to send your message. 3, 2, 1. No more messages. Now we can check the right answer. We can work using graphing. It's a very rough graph, but have a look. We have let's say a ball. He's throwing a ball upwards 10 meters per second, right? And this ball will go up, 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 and the gravity is pulling this ball down, right? The ball is slowing down because it's getting up, but it's lower and slower. At some point, the ball just stops. And stop. The speed of the ball at this point is 0. It's going to be 0, right? The gravity is pulling it down, and then at some point the ball stops. The speed is 0. And now the ball is returning, it's coming back downwards. The speed is increasing in the opposite direction. So now it's coming down, 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 down. The speed is increasing. At this point, the exact same point where the ball was thrown up, is going to have a speed downwards, and this speed has the same value of the speed that it was thrown up. But in the opposite direction, going down, we can even say this is a negative 10 meters per second. So the right answer, if we think about this graph here, it's a very rough, very simple graph, but if you think about this graphing solution, the right answer is going to be 10 meters per second. You can also write negative 10 meters per second, because the ball is going in the opposite direction now. On today's quiz, we have to find the coordinates of the vertex. Write your answer as an ordered pair. And you don't need to do calculations here. You need to visualize. You need to see on the graph what's going to happen. Okay? So let's get the first example, letter A. G of x equals x squared plus 1. Let's say g of x equals to x squared, just x squared. That means the vertex is 0, 0, right? But then we add this positive 1, and we can draw a scratch. G of x equals x squared. The vertex is 0, 0, and this is x squared. When we add 1, we're going to move this, we shift this graph upwards 1 unit, 1 on the y-axis, and this is the new graph, x squared plus 1. That means the vertex now is going to be x equals 0, y equals 1. Okay? So when you add 1, the vertex is x equals 0, y equals 1. When you write down your answers, don't forget the parentheses, because this is an ordered pair. And the order is important. The first one is x, the second one is y. So write like this, parentheses, x equals 0, y equals 1. Now, think about letter B. Let's say now we are adding 1, but inside the square. We have the parentheses and the square. Let's say r or x equals just x squared. The vertex is 0, 0. But it's not the case. We are adding 1 inside. So let's work on the scratch. Now we have x g of x, if it is x squared, it's going to be this, the simplest case, but it's not. It's x plus 1. So this will shift sideways to the left or to the right. In this case, when you add 1, you shift to the left, and this is the new graph. This is x plus 1 squared. The vertex is going to be x equals negative 1, y equals 0. So, get back here to the question, letter B. We are adding 1 here. This is squared. The effect on the vertex is you shifting the graph to the left, and x equals negative 1, y equals 0. Yeah, clear, right? Perfect, nice. Well done. See? Don't forget the parentheses. This is an ordered pair, and the order is important. First, negative 1, which is x. Second is 0, which is y. Great, and I'm going to give a couple of minutes to work by yourselves. I will also check attendance. On letter I, always start with the basic, with nx equals x squared. If you have something like that, the vertex is 0, 0. But now we are shifting downwards. We are subtracting 1 over 5. This means shift the whole graph on the vertical line downwards, on the y-axis. So I have to move to change the y-coordinate to -1 over 5. Let me show the graph, how it looks like. Here on the side, you start always from the basics, x, f of x or n of x equals x squared, and then you're going to shift downwards -1 over 5. Now this is the new coordinate of the vertex. X equals 0, y equals -1 over 5. Okay? Letter I. Letter L. The subtraction, you're subtracting a number, is not inside, it's not under the square, so it's kind of the same thing. M of x equals x squared. If you have just x squared, the vertex is 0, 0. Right? So this is x squared. Now we're moving up or down, subtracting -5 over 4. That's as a shift downwards. This point here is y equals -5 over 4. And this is the new vertex. The new vertex is x equals 0, y equals -5 over 4. And let me just take the chance to show the difference if you're looking at the next one, letter P. See, now you are adding 3 over 2, but it's inside the parentheses, it's under the square. So if you have r of x equals x squared, the vertex is 0, 0. Let's draw here the graph. This is x squared. So now we are adding positive 3 over 2 inside the square. That means we are shifting to the sides. We're going to shift, this shifts to the left. X equals -3 over 2. And that's going to be the new graph. X plus 3 over 2 squared. That means if you add 3 over 2, you're going to subtract 3 over 2 from the x coordinates. And that's it. This is all the time we have for today. If you want to check the answers,